Hello, welcome to NFI online video tutorials. My name is Rajveer, and in today's lesson we will talk about relays. We will see how relays works, we will see various types, and then we'll see some examples. If you're not sure about how does a relay look like, this is a general form of a relay. Here we have this electromagnet. Inside it we have a coil and with some contacts, and this is the base. So let's explore what is inside the relay, how does it work, and also how to read the symbols of a relay, and then how we can make a circuit using those symbols. All right, so starting with the main basic fundamental of relay. So if you notice, here we have the coil, this one. This is the coil. So what happens when you energize the relay, which means when you supply the power to the relay, this coil generates some electromagnetic effect. Okay, with this electromagnetic effect, if you see these strips, these strips moves. All right, because of the magnetic effect. And when you de-energize the relay, because of the spring action, it comes back. All right, so it attracts and retracts the strips using the electromagnetic action. And this is the basic fundamental. By using this movement of the strips, we isolate the circuits, we latch the circuits. All right, and how we do that, let's have a look. So if you see here, this is a schematic diagram of the relay, and this part, this number 8586, this is the terminal for this coil. Okay, so this coil and this coil is the same. This is a representation of the coil inside the relay. Okay, so what happened when you energize some voltage at 85 and 86? This strip move. All right, so if I change my pointer, this strip which you see here, these are these strips. Okay, physically. So what happened when you energize this coil 85 and 86, this strips moves to this part. So this will be like this. All right, so this is the movable part, and this movable strip there is a common term for that. We call it common. All right, if you have heard about this common on PLC or in relay, it is generally represented by C or COM. This is the common. So you have to make sure when you are trying to connect common, this is the part which switches the position. Okay, so now there are 2 points. We have 87A and 87. So when the relay is not energized, suppose you haven't provided supply. So if I take eraser, suppose relay is not energized. So initially the common will be at 87A. Okay, so this 87A, the point is known as, very simple, it's NC, which is normally closed. Normally closed means when relay is off and the point which is connected to common, that is a normally closed. So normally means when relay is off. Closed means this is closed with contact with common. Okay, so this NC part is the contact which is normally connected to common when relay is not energized. Okay, so when relay is energized, this contact is connected to 87. So common moves to 87. So this part is called normally open. Now normally open means this contact is open when relay is off, but this contact is closed when relay is on. So normally means when relay is off, this contact is open. This is not connected to common, but this contact is connected to common. Okay, that's why it is called normally closed. Just because of this movement of this common terminal, we latch the relay, which we will see that later part of the video. So once you find a relay, if you have a relay on your table, when you read their symbols, sometime you will find drawings like that. So you have to immediately read the strip, which one is moving here. So this strip is moving, so we call it common. And if it is connected to 87A, it means 87A is NC. If it is not connected to 87, it means that's NO. This is always, the diagrams are always in a position when relay is off. Right, so sometime if NONC is not mentioned, which is quite likely in most of the cases, they only mention the numbers, so that you will find numbers written here. Let me change the pointer. You will find generally the numbers are written on this part of the relay, or this part, or this part, and the same numbers are printed on this coil. Okay, sometime, so you have to match the numbers. So numbers you can match only if you know the symbols. So this is the symbol of coil, this is the symbol of common, that's NC, and that's NO. So let's see some more examples. Now if you see here, this part is the coil, the same as this one, A and B. Now this is again a symbol, and this is a symbol of normally open. because you realize this is not connected to point B. So we only have one normally open contact in this relay. This is a complete symbol of a relay. And we call it SPST. SPST is single pole, single throw. Single pole means it has only one common. If you notice here, this part is a common, C is common, and B is NO. So single pole, single throw means it only is only, connected to one point. There is no another NC point. So if there is no NC point, we call it single throw. Let's come to this one. It says single pole, so it has only one common. It is also already C. And double throw. Double throw means it is connected to B and it can be connected to A as well when this is on. So when this relay is energized, this will be connected to A. So it has one NC and it has one NO. This is called single pole double throw. Okay. Now let's see this example. Double pole single throw. Now here we have two common. A1 is one common, C1, A2 is another common, C2. And it has only single throw means it can only be connected to one point. So this part will not go here, it will only be connected to B. So B1 is my NO. Similarly, this strip is connected to B2. This is my another NO. So when relay is energized, if you see this dotted line means when this coil is energized, both the strips will be close together. So both are controlled at the same time simultaneously. All right. So let's see this part. It says double pole double throw. So two common, because double pole double throw means it can be NO, it can be NC. So if you see this line, so when relay is off, C1 is connected to B1, B1 is NC. Similarly, B2 is NC. When relay is energized, this will come here, this will come here, and both will be connected to A2 and this will be connected to A1. So these are your two NOs. So this is double pole double throw. All right, so similarly here we have four pole. So four pole means we have four common paths, common terminals. Now this symbol looks a little bit different from the others, but the general fundamental you will find it's quite similar. If you notice, this N is coming from here and this is the movable part which will move up and down. So this 9, 10, 11 and 12, these all are common. Okay, independent common. And this is already connected to 1, this one is connected to 2, this one is connected to 3 and 4. So this is normally closed. And 5, 6, 7, 8, these are normally open. So when this coil is energized, now coil number is 13 and 14. When you provide signal to 13 and 14, this coil will be energized. This is an LED and this is a current limiting resistor to glow the LED. So this coil will attract these strips down. So all of these strips will be coming down and connected to, this will be connected to 5, this 2 will connect to 6, 3 connected to 7, 4 connected to 8. So these all are NO terminals and these will be connected to the common. So whatever signal you provide to common will be going to NO. So this is how you can read the symbols from the relay diagram, which is printed on your relay, or if you have a sheet, the manual of a relay, you will find the same industrial symbols, and you have to find out which one is NO, which one is NC. Now comes the part how to use NO and NC and how to make a circuit. So once you are through with this part, let's come to the circuit diagram. So I'm going to use a software where I'm going to draw some circuits. So let's see the first circuit to latch the relay. So I'm going to use some power source. We have line 1 and neutral. All right. So with line 1 and neutral, I need some switches to turn on the relay. So I'm going to use a switch which is push button and normally open push button. I will connect a line signal to one part of the switch, and the second part is going to energize my coil. So this is one of the, I will target with coil R1, coil of relay 1. This is one of the symbol of a coil. Now sometimes the symbol varies from this one, and sometimes you will see like this one, or sometimes you will see like a rectangle. So all the symbol represents the coil. Okay. So I'm going to connect this coil directly to my switch, and this goes here. All right, so this is just the diagram for a switch connected to a coil. Now we need the contact. This was just the coil. If you notice here, this coil, you can say, let's talk about this one or this one, 85 and 86. Okay, so if you find 85 and 86 number here, I can just type it for you. Let's design the circuit diagram based on the relay we have on presentation. This is a kind of 85 and 86. Okay, so if you have this relay with you and you want to connect the coil, so to 85 you will connect the point coming from the NO switch, which is line, and 86 will go directly to the neutral. This one directly go to the neutral. All right, so this is how you energize the coil. Now let's talk about the contacts. So we have to latch this relay. So we'll take this contact. Now this is question mark because I have to tell which contact, which relay is linked with this contact. So I'll just link it to coil R1. So this contact is now linked to coil R1. This is just a software thing, but you know that you have contacts in your relay. So the common is 30, NO is 87. So we are using this as a symbol for NO contact. This is another symbol of NO contact. So common was pin number 30. So I will just write here. The common I'm connecting directly to my line voltage. And this voltage is either 220 volts or 110 volts, depending upon which country you belong, because somewhere we have single phase 110 volts and sometimes single phase is 220 volts. It depends on the location of where you live. All right, in my country we follow 220 volts, so I consider L1 as 220 volts. So 220 volts is coming directly to the coil, and this 220 volt is going to the common of my coil terminal, my relay terminal, NO terminal. So this 30 is NO. And then we have, this 30 is common. All right, the NO part is this one, 87. So I'm going to connect 87 right now directly here, just to show you what's going to happen. So what's going to happen if I go online now? If I energize this coil, if I press the button, you will notice this coil is on, and because of the magnetic effect of this coil, this contact is closed, which means this contact has moved from common and is connected to NO. Okay, you can imagine like that. This is energized, so it attracts the strip, and this contact which was open, it's get closed. So the contact has been closed, and now the supply from L1 is also going from here. So if I remove the switch, the supply will continue go from here, and this will latch my coil. So it means my coil is latched, or my relay is latched. Okay, now to unlatch this relay, to turn off the relay, what I can do in the circuit, I can do anything, because I haven't provided a broken path which will break the supply of the coil. Okay, so we have to have an NC switch which should be used to break the contact. So I will take target as X. So this, I will remove this line and I will include an NC switch. So now your circuit has been changed. You have to connect the wire coming from the switch, also from the NO contact of the relay to an NC switch, and then this wire from the switch goes to my 85 coil number terminal of the relay. Okay, so now when you do the latching, this is latched because this is normally closed, passing the signal already. If I press it, this will be unlatched. So here it is latched again, and this is unlatched. So this is like a simple latching circuit of a coil or of a relay. Now if you want to latch a motor, let's say single phase motor, in this case that will be very easy. You just have to take the motor. I will target as motor. I will rotate it, and I can just connect it in parallel to it. This is the one way to do it, because this will also latch my motor. So if you notice, if I latch the coil, it also latch my motor. And this is going to unlatch it. Many a times what we do, we don't connect motors like this. We take another NO contact of this relay, and we connect the line to one part of it, and the another part goes to my motor. Okay, and this part goes to my neutral. So this is quite similar, because if this is being controlled by the coil, this will also be controlled. Now in this case, this is double pole single throw, because we don't have any NC. Double pole means we have two commons, so this point number is different from 30 and 87. There are two commons and two NOs. In this case, motor will also latch because these both common are moved to NO when this is energized. So if you have three commons, all of three will be moved towards NO. This is what is explained by this dotted line, okay? This dotted line. Because when you energize the coil, all the NO and common will be linked together, okay? So this is like how you latch a motor, and this is how you unlatch the motor. This is for single phase latching and unlatching. All right, so this was about how to latch and unlatch the relay. In the next video, we will see how to latch and unlatch a three-phase motor instead of single-phase motor, and also we'll see how to change its direction and how to change the direction using limit switch, which was like most of the time I receive an email because we have this video in our YouTube where we have shown how to change the direction using a limit switch, and many people were asking about the circuit diagram, so I'm going to explain that in the next video. All right, see you. Thank you. All right, before we move to the next video, I forgot to mention that in case if you have a coil which is energized by a DC voltage, because we have two types of coil, one is AC voltage and one is DC voltage. If you have the coil or the relay which is energized with DC voltage, in that case you don't have to connect line and neutral because this will damage the relay. So what you will do in this case, how you will change the circuit, all you have to do is just connect your latching circuit with 24 volts and your power circuit with line and neutral. So what you have to do is you will take the 24 and 0 volt supply from your power supply in your panel. So I will take 24 here and 0 volt here. Because our coil is DC voltage energized, we can't give it AC. So we will use one coil, one terminal of NO and common to latch the coil, which will be like 24 volts coming from here. This will latch the coil, and the another common of the same relay, another common is connected to line, and this neutral goes directly here. So when you energize this one, you will see the color has been changed. This will also latch my coil, and this will latch the motor which is running on line and neutral. This is a kind of isolation as well. If your motor is damaged, this will, if it is short circuit, this will damage this contact, but your relay will be safe. And this is how we also isolate the high power circuits with low power circuits, low power control circuits. Like if you have a PLC, we connect relay to the PLC outputs, and then we isolate the PLC outputs via relay to a high power circuits like motors or solenoids. Okay, so many a times we have controlling power of 24 volts in our panel, and we have 24 volts relay, so that's how you will connect it. But high power circuits you generally connect with another pair of common and NO. Or also in case of three-phase motor, instead of relays or in parallel to relays, we connect the contactor for another level of isolation. We'll see that in the next video, how to use a contactor. All right, see you then.